Okay, so the first thing I want to talk about is something called counting principles. The whole unit behind like probability is really about trying to come up with the most combinations possible sometimes. One of the best overlaps with this is security. Let's say you're trying to make a password for your cell phone. If the password was 1 digit, I could probably guess it. I'd type in 1. Oh, wait, and I type in 2. Does that make sense? Would a 1-digit password be very secure?
No.
What if you had a 24-digit password?
Yeah.
You'd forget it, obviously, right? But would it be a secure password? Yeah, I think you'd agree, right? Especially on, like, say, a computer, where you could use letters, numbers, capital letters, maybe like a period or a question mark. Does that make sense? There's a whole field based on this concept called cryptography. Has ever heard of that before? Cryptography, like trying to encrypt stuff. Okay. Yeah, the longer the password, hopefully the more secure it would be because you can't guess the password. A very basic type of hacking uses something called a brute force algorithm. Have you ever heard of that before?
You break into it, you like break it.
But like literally what it does is it tries all the combinations. So let's say you had a 4-digit password. It would try 0000. Then it would try 0001. Then it would try 0002. And eventually, once it stumbles on the code 2973, then it would break the password. Does that make sense? That's what a brute force algorithm does. As long as it's not like a lockout code, like on my cell phone, if someone incorrectly does the password, like say 5 times in a row, then it locks you out, kind of thing. That's the sort of stuff we're going to talk about here. The total number of either probabilities, so putting a percentage behind it, or just the number of arrangements that you can make. How many ways can you arrange your password? So the first thing I want to talk about then is a tree diagram. A very basic place to start is just to draw out all of the outcomes. Let's say you guys go to the ice cream store and they say you can get either a sugar cone or a waffle cone. Okay, there's your first choice. Then they say you can get 4 choices of ice cream: chocolate, vanilla, strawberry, or mint. How many ways can you go get an ice cream cone? And the answer is 8. You could go sugar with chocolate, that's 1. Sugar with vanilla, that's 2. Sugar with strawberry, 3. Or sugar with mint, 4. Or you could do waffle with chocolate, that's 5. Waffle with vanilla, 6. Waffle with strawberry, 7. Waffle with mint, 8. Does that make sense? You just draw a tree out. Let's try another example. Hannah plays on a soccer team. They've got 3 sweaters and 3 different types of shorts. How many ways could they basically outfit their team? Well, here's a tree diagram. You could do red sweater, red short. Red sweater, black. Red, white. White, red. White, black. White, white. Black, red. Black. You get the point. Does that make sense? This is called a tree diagram, where you basically just map out all the possibilities. In lower level type problems, like very basic ones, you can draw a tree diagram. But you normally don't want to actually draw a picture out every time because it gets a bit ridiculous. Does that make sense though? So let's try a different one here. Let's say that you go to a restaurant. By the way, if you guys haven't picked up on this already, the amount of time you're going to spend on each question sometimes is going to be like 30 seconds. Because like I already flew through 2 examples without even batting an eye, right? So there's a lot more questions we'll just do. Let's say you go to a restaurant and you got 4 choices of appetizers, 2 types of entrees, and 3 types of dessert. How many ways could you eat? So I'm going to just draw out a basic tree diagram then. I might say that you could start with wings, or you could start with nachos, or you could start with breadsticks, or you could start with soup. So I might start off like that. Well, then you want to get your entrees. So let's say you get wings first. Wings, then you could buy steak. Or with wings, you can buy ribs. Or maybe you got nachos with steak and nachos with ribs. Or you had breadsticks and steak, breadstick and ribs. Or soup and steak, and soup and ribs. I know, I don't want steak and ribs now. Okay, but we're not done. Now there's dessert. So let's say you got wings and steak, then you could get ice cream. Or wings and steak and pie. Or wings and steak and apple crisp. I know, you gotta kind of write kind of small here. Or wings and ribs and ice cream. Wings, ribs, pie. Wings, ribs, apple crisp. I'm just gonna start writing IPA just on all of these if that's okay. Alright, so how many different paths could you take at this restaurant there? I'm going to count them all out in a second here. You could do one, like you could go like that. That's one path. 2 paths. 3 paths. 4 paths. 5 paths. 6 paths. I'm going to speed up a little bit here. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there's 24 ways that you can eat your supper at this restaurant. Does that make sense? Anyone have issues with the tree diagram? Cool. We're not drawing those again. Okay. Like, once we talk about a tree diagram once or twice, unless I like make you do it in a question, which is pretty rare, we're going to stop with that and we're going to try to speed things up.
Couldn't you just go 4 times 2 times 2?
That's actually what the theorem is going to be in a second. Yeah, what we're just going to do is we're going to times these numbers together. Yeah. Before I get to that, actually no, let's do that first here. Let's do what you just mentioned. What Shodi just came up with is actually a principle called the fundamental counting principle, where all you do is you just time some numbers together. Like I said, so long as you can handle basic math, that's it. Just multiply numbers together. So fundamental counting principle basically says times things. This is a notation, Devin and Dakota, that we didn't use in 30-1, but we're going to start using in 30-2. So I just want to explain this one. What this means is n refers to the number of ways that you can do A. So that might be the number of ways that you can have soup. And B then is the number of ways that you can have steak. And C might be the number, like N stands for number, okay? The other thing I want to show is this notation right here. This little symbol right here is a shorthand symbol for the word and. Okay, I know it maybe doesn't, why would you just write the word and? But mathematically, like in symbol logic, this upside down U means and. So if you want to do soup and steak and salad and dessert, that's what this notation means. Long story short, you just times numbers together. I always like doing this activity with the class. I want to talk about Subway. Yeah. I pulled this slide off of Subway's website years ago. They claim that you can make over 2 million combinations. My 30-1 class, we did this task where we tried to figure out how many different ways you could buy a sub at Subway. Let's try it. So, hypothetically, we're on a field trip, we went to Subway. What is the first thing they ask you when they come in the door other than like hi?
Bread.
Okay, so my first question then is, okay, actually, good question. Sometimes the first thing they might ask you is foot long or 6 inch. So in terms of like an option, basically you then have 2 options. You could get a foot long or a 6 inch.
Or a 9 inch.
No.
Is that actually an option now or no?
No.
My little brother got it once.
Oh.
They got it for him.
Okay, so then what's the next question you get asked? What type of bread do you want, right? How many choices of bread are there at Subway?
7.
There's brown, white,
6
Italian,
six
Italian,
There's
Italian, and then Italian pepper cheese, and then flatbread. I
Flatbread.
go there way too
So-
much. There's like a grain one.
There's
Should I say like 7 types of bread?
Sure.
Alright. Pardon me. What's the next thing they ask you?
Cheese.
Alright, how many types of cheese do they have there?
Wait, what? No. They go from bread to your sub.
There's
white.
Do they do cheese next or do they do the meat next?
No, they do meat next.
They do meat next?
Yeah. And then they say what kind of cheese.
Okay, we'll do meat first, then cheese. Okay, so then you do meat. Okay, this one's a little bit tougher. If we had to guess how many types of meat there are, just like
16.
16?
Yeah.
16 different things like you could have. Sure, let's go 16 types of meat.
Go on.
Now, one of the limitations to this question right now is that I'm also making it so that we're only choosing one type of meat. And when we get a little further into the course, we could talk about, well, what if you chose 2 types of meat or 3 types of meat if you were allowed to, right? Where you're like, I want bacon and chicken and ham on my sandwich.
Cheese.
All right. Next question they ask you is, how much cheese do you want? I'm thinking white, cheddar, orange, shredded, Swiss. 4 types of cheese probably. Okay, I'm a little out of room here, so let's keep going down here. Then they ask you about whether or not you want to toast your sub or not. How many choices do you have?
2.
Yeah, basically you have the choice of yes to toast or no to not toast. By the way, if I want to do a bit of an aside right now. You guys ever heard of the term binary, like coding in computers? Maybe you've heard this phrase before. Computers will actually write code based on zeros and ones, on and off switches. Basically, the concept of yes or no. Just like the Subway question here where I ask you, do you want to toast this or not? Code is made up of 1, which basically means on, or 0, which means off. Ever heard that before? Okay, after you get to the toast, then you have an issue. Then they ask you about vegetables. How many types of vegetables are there?
There's a lot.
25.
I'm going to guess,
36.
I don't know if there's that many.
18, I counted the rows.
It's only 10.
It's like 6 rows, like 1, 2, 3, 4, 5, 6,
More
7,
than 10 there.
Okay, so it goes like a 6x3 grid there?
Yeah.
Okay, so what do we got that? There's 18. It takes forever to get through all of them.
I got a flashback.
It's only 10.
Okay, now, here's a common mistake. If I ask you about how many veggies you want, the answer's not 18. Because you're being asked a series of yes or no questions to veggies. Because you're being asked, do you want lettuce, yes or no? So what we actually have to do is for each veggie, we have 2 choices. The faster way of doing that is like this. 2 to the power of 18, which basically means 2 times 2 times 2 times 2 times 2 times 2 times 2, because there's 18 choices of veggies.
What
That
if
makes
you
sense.
want no cheese?
Ooh. So then I guess there's a 5th possibility. If you don't want cheese, there's 4 cheeses you could have, plus the possibility of not having cheese.
What if you can understand? You don't want any bread.
So you're gonna ask?
Well, they have
Where would you
salads.
want any meat?
I've seen people go there not on meat. It's stupid.
Okay, so then maybe we should add a 17th type of meat, because maybe you could just choose not to have meat on the sub. I think you do have to choose a bread, though. I think that...
Then it just turns into a salad.
Okay, last questions. You then have a choice of sauce.
And salt and pepper.
Okay, let's do salt and pepper in a second. Sauces. I'm thinking there's probably, what, about 12 sauces in that little container there? Is that too many?
Yeah.
Maybe 8?
Dang, they're loaded.
It really is. Okay, how about this? How about there's 8 sauces? Well, again, when it comes to all the sauces, you're being asked yes or no. Do you want mayo? Yes or no. Do you want mustard? Yes or no. So based on sauce, you're getting asked it's 2 to the probably 8, because there's 8 sauces. Yes or no. Saucy. Okay, and then last question, they ask you about salt and pepper. So I guess with salt, for example, you could say yes or no to salt. And pepper, you could say yes or no to pepper.
But you
Well,
can
you
say
can both.
no.
Well, but doesn't both, isn't that covered? If you said yes to salt here, that's one of your possibilities. And if you said yes to pepper here, that's one of your possibilities.
I guess.
So, in a way, you have yes or no to salt, and you have yes or no to pepper. So let's grab a calculator now. Let's figure out how many possible ways you could make a sub using this information here at Subway.
6.3 times 10.
Devin.
Guys, slow down. You've already been to this class, or at least to this lesson. Okay, so follow with me here. 2 types of size of sub, 7 types of bread, 16 types of meat, plus the possibility, I guess, of not having meat on a sub. In Southern Alberta.
I don't know how to do this.
Times by 5 types of cheese. Well, 4 types of cheeses plus no choice. Times toasted or not toasted. Times by 2 to the power of 18 for the 18 different veggies we have.
That is definitely
Times by 2 to the power of 8 for the different sauces there are. And then 2 times 2 for the salt and peppers.
6.3 times 10.
How big is that number? let's write it out here. In case you don't know what that number means. 6. Then we need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's how many combinations there would be at Subway. And I really think we're actually probably on the low side. Because then, do you want chips? Do you want a drink? Do you want a salad? Soup, by the way?
Cookies.
Or if you want a fountain drink or a bottle drink.
So, I mean, in terms of number, this would be the first 3 digits. That would be the hundreds of thousands. That would be the millions. We've got at least 600 billion combinations at Subway.
That's some variety.
That is some variety. Yeah. You could try something new every day, and you would never even come close to trying all their combos.
Other than that,
And then all of a sudden, they come out and say, by the way, now we have avocado. And it makes even more combos.
No, I think we found the avocado.
Oh, avocado was part of the...
Yeah, avocado is.
Okay. Okay. So anyways, back from Subway. The concept I need you guys to know today then is basically just how to times numbers by each other. So long as you can use some rational thinking and figure out what to multiply, that's all you have to do. So let's try some faster examples now. You guys still with me?
Yeah.
We'll get to that in a bit. You're a little ahead. Okay, so let's say you have a 2-sided coin, 4-sided die, and a 3-sided spinner. Well, I mean, the fundamental counting principle basically just means, say, you have to flip a 2-sided coin. And, by the way, and means times. Okay. And you have to do a 4-sided die. And you have to do a 3-sided spinner. Times them all together, there's 24 ways to do this.
Ooh.
Think security now. You ever watch one of those kind of James Bond-y type movies where they have to break into the safe? But the first thing they have to do is they have to get through the laser grid. And they have to do the combination. And they have to get past the biometric eye sensor. And there's a counterweight, so when you take the crown jewels off of the thing, you got to put something else in its place right away. Okay. Whenever you have the word and, you have to multiply. Multiply makes the number bigger. Bigger means it's more complex. Okay. When it happens, and we get to these examples here, if you ever have an or scenario, or means add. Okay. Or means to add. Like if I ask you, how many ways could, I gotta think of a good example off the top of my head here. There's 4 items on the table right now. I'm going to ask you, how many ways could I select an item and be able to take a drink from it? And you'd say, well, there's 2 ways, because there's this one, or there's this one. 1 plus 1 is 2. And I know that probably sounds insulting, because you just looked at it and said there's 2 of them. But the rationale is there's 1 way I could take a drink from this water bottle, or I could take a drink from this water bottle, therefore there's 2 ways. Does that make sense?
Don't you put water in that Tupperware thing and drink it out of there?
Oh, fine. Good points.
And the tape.
You can make a bowl out of the tape.
Okay, let's try another example. Let's say you have like one of those little luggage containers, and there's just like a little 3-digit lock thing on there. You know, it's not overly secure because you probably could just break it open with a pry bar anyways, right? But, you know, it gives you the illusion of security. No one's rifling through your luggage in the airport. And there's a 3-digit code. My question is, how many 3-digit codes are there? Because the more codes there are, the more secure it should be. So, for the first digit, how many possible digits could you run through on like one of those little rotator things?
10.
10.
There's 10 because of 0.
There we go, yeah.
Boom.
Been here before. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So there's 10 possibilities.
10 times 10 times 10.
That's actually the answer. 10 times 10 times 10.
So 30.
Not 30.
Wait, no.
That's 10 plus 10 plus 10.
That's worse.
Okay, and that's actually a good talking point right now. Let's say you want to break open the lock. You have to, can you guys still focus, okay? You have to get the first number right, and the second number right, and the third number right. Because you have to get all 3 numbers right to break open the lock, it's an and scenario. I don't know how you'd make a lock like this, but in theory, if you had to get the first number right, or the second number right, or the third number right, which I don't know how you make a lock like that, but if you just had to guess one of the three numbers, then there'd be 30 possibilities. Well, much easier, right? So. Okay. Let's change this up a little bit. By the way, just to save time, if you guys are still with me here, just to save time, often in this section here, rather than actually timesing these numbers together, I'll assume that you guys can use a calculator, and I'm just going to leave the answer at this. But you guys could multiply them together to get 1,000.
Oh, so we should write out the answer like that?
Well, I'm just going to leave it like this, but could you guys multiply them if you had to?
Yeah.
Okay, let's try the next one then. Let's say that a digit can only be used once. For some reason, the lock is set up so that once you use the number 5...
Jennifer Revere, please dial 103. Jennifer, dial 103.
So I'm going to draw 3 lines, one for each of the different kind of numbers you got to select. How many choices do you have for the first number? I'd say 10. But here's the change then. Once you've used whatever your first number is, you can't use it again. So let's say you use the number 5. Well, then you can use 0, 1, 2, 3, 4, 6, 7, 8, 9. So there's 9 choices left. And then 8, because the numbers are going to go down because you have fewer possibilities if you're not allowed to repeat a digit. Again, I'm not actually going to multiply those numbers together. You guys can just, well, you can just do it then.
So number 20.
All right, moving on. I like this question. Telephone numbers are in a way the same sort of thing. Why don't we do this question here? You guys look a little restless. Then we'll take a break.
Yeah,
Okay. I need your focus though, because I got to talk a lot. Telephone numbers in a way are an arrangement of numbers. I made this question based on Fort Macleod. Pretty much every home number in Fort Macleod is 553, correct? I don't know if that's changed yet, right?
587. Oh, wait, no, that's a phone number. That's not a phone number.
Yeah, okay, so like a home number, right? So let's say that a telephone number has to start with the numbers 553. But then it could be any digit. How many numbers are possible? Well, let's talk this through then. The first number has to be a 5. How many choices are there then? I know it sounds kind of silly, but there's one choice. You have to type in a 5 first. If you accidentally type in 653, you're not following Fort Macleod anymore.
Yeah.
Then you have to type in a 5. There's one choice there. And then you're typing in a 3. There's one choice there. You have to type in a 553 to start, right?
Yeah.
But then after that, I don't know, what's the school's number? 4411. How many choices could there be for this digit?
9.
Actually, 10.
10. Yeah, 0.
Because you can still use a 0. So there's 10 choices here because I don't know what this number is going to be. It could be anything. And I don't know what this number is going to be. But it could be anything, couldn't it? Anything from 0 to 9. And really, this one and this one. Well, based on that math, there would be 10,000 phone numbers possible in Fort Macleod. That's probably sufficient for Fort Macleod, isn't it? Because there's lots of cell phones, and those don't even use those digits. Maybe some office buildings or the hospital uses like more than one line. But hypothetically, let's say that there's this one little word right here. Let's say that for some reason 10,000 phone numbers is not enough. And they need to start making some more phone numbers available. So they open up some new digits. They say you could start with the digit 6. Well, if you have to start with the digit 6, that means you have one choice. Then it has to be one of the digits from 3 to 8. How many digits are there between 3 and 8? 3, 4, 5, 6, 7.
Can you count 8?
Because you can count 8. From 3 to 8 means you got to count 3, 4, 5, 6, 7, and 8 itself. So if the next number is from 3 to 8, there's actually 6 possibilities for that.
And then 10 and 10 and 10 and 10.
And then, yeah, then there's a 10 for this one, and then 10 and 10 and 10 and 10. And I believe that number is 600,000 phone numbers. That'll probably cover Fort Macleod. And Lethbridge. And Red Deer. And Medicine Hat.
Let's go back to an algebra.
Did I lose you on that one, Shelly? So like, where did I lose you?
You didn't lose me.
Oh, okay.
I just don't like.
Okay. It's a very different type of math though, isn't it? Like it's critical thinking.
algebra.
We're not done though. One last thought.
What?
This final word here. How many telephone numbers are possible?
Or
If
you add.
that's the thing. So let me talk through this here. When you type in a telephone number, you have to type in the first number, and the second number, and the third one, and the fourth one, and the fifth one, and the sixth, and the seventh. Technically, you have to do an area code as well, but this was before they made area codes possible, so ignore that concept. Or you could type in a totally different combination of numbers. Does that make sense? So the final answer then would be 10,000 plus 600,000. So there's actually 610,000 total numbers.
Wow.
Some of this was due to adding, and some of it was due to multiplying.
Chico.
So far, so good? All right, take a 5-minute break. I need you to be able to keep focused. So go take 5, and then we'll keep going. Okay. So one of the places that I really like to talk about examples in this section, then I like the gambling section. It's kind of fun. I don't mean to make you all gamblers if you're not, but like card games, poker is a great example. Anybody ever watch like them do poker on TV and they put like the little percentages in the corner as who's gonna win? You guys ever watch poker on TV? Or is that boom over and no one watches poker anymore?
I don't watch poker on TV.
Have you seen it before at least once?
I've
or?
seen it before.
Okay.
Aaron tried to teach me how to play.
Fair enough. So, really, poker players are not gamblers so much as they're mathematicians. Most of the best poker players are able to calculate odds very quickly. Let me give you an example. Let's say that you're playing a poker game, and in order for you to win, you need a 10. And you know that there are 3 more 10s out there. Well, that means that you can figure out your percentage of winning because you have 3 chances to win out of, say, maybe 40 cards left in the deck. So you figure out your percentage of winning. And then what the poker player does then, guys, focus, would you? They figure out how much money they would win. So like, let's say that, let's change the odds a little bit. Let's say that 1 out of every 2 times you'd win. That's not bad odds. But let's say that in terms of money, let's say that you need to pay $5,000 for the pot. But if you win, you'd make $1 million. So that again. Let's say that your chances of winning the game are about 50-50. Half the time you win, half the time you lose. But in terms of gambling, you need to pay $5,000 to stay in the game. But if you win, you make $1 million. That's a good bet, isn't it? Because like you might lose your $5,000, right? But if you lose your $5,000, you're out $5,000. But if you win $1 million. Does that make sense? And calculating those odds and whether it's worth it, that's what poker players and that's what like the professional gamblers, that's what they do. They're not addicted to gambling just for the thrill of it. They're doing math odds in their head, trying to figure out whether they should play the game or not. So we can do this on like a lower level here. You guys ever used deck of cards before? You get the concept of there's 4 suits and 13 cards from like 2 up to 10, then Jack, King, Queen, Ace. You guys know this? So let's try an example here. Let's say that you're playing a game and you win if you get a black face card or you get an ace. So let's say this is how you win the game. A black face card or an ace. Well, here, that is a black face card. That's 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 a black face card. So there's 6 ways that you could win with a black face card. Keyword there. Or an ace. Well, that means that you could win with the aces here, the ace here, the ace here, or the ace here. So 4 aces. That keyword of or means you should add them together. 4 and 6 means you have 10 ways to win. That makes sense? You could win with any of these 4 cards, or with any of those 6. Keyword or, meaning that now you have 10 ways to win. Are the odds in your favor? So borrow from...
No.
Well, on this one here, no, the odds really aren't in your favor. If I had to wager on this, okay, now if you gave me like say 1,000,000 to 1 odds, if I paid you $1 and you paid me $1 million, yeah, I'd bet on this, I guess. But if like let's say I paid $1 to earn back $1, I'm not going to win very often, am I? So I need the odds to be like the payoff to be good enough to actually play this game. Let's try the next one here. Let's say that you had to either get a red card or a 10. How many red cards are there in this deck?
26.
Yeah, half of them are red. So there's 26 red cards. Or a 10. How many 10s are there?
4. 3.
So you might think the answer is 30, but it's not.
Wrong.
It's 29.
Why is it
No, it's 28.
So dumb.
Oh yeah, because we can't read the other 10 cards.
Okay, so I'm going to circle them here. Here's all of your red cards. There's 26 of them. And here are all of your 10s. Do you see how I've circled these ones twice? Well, I don't have extra ways of winning with the 10. What I really have are 26 ways in which I win with a red card. The red 10s, I've already counted the red 10s as ways in which I win. I get 2 more with the black ones. And so sometimes you have to be careful not to count something twice. Does that make sense? This is a concept that we don't actually use in 30-1, by the way. But the word we use for it is on the next slide. We call it mutually exclusive. There are certain things that cannot happen at the same time. Like, for example, let's say that I want you to draw 2 cards, and I want you to draw an ace or a king. Can you pull a card out of the deck that is an ace and also a king at the same time? Well, no, it's one or the other. It's either an ace or it's a king. No worries. But let's say I want you to draw an ace or a club. Well, you could draw one of 4 aces. You could draw one of 13 clubs. There is also the possibility that there is the ace of clubs, which kind of counts in both categories. Does that make sense? So you got to make sure that you don't accidentally count something an extra time because you count it twice. In terms of notation, you guys might see this. Okay. The number of ways that A and B can happen sometimes gets represented with this symbol right here. This means and. And means multiply. So if you need this to happen and this to happen, times them. But if you need this to happen or this to happen, the symbol we use is a regular looking U. This refers to or, and or means add. So and, multiply, or add. Don't count anything twice by accident.
Wait, so I don't understand. Like,
This is just the notation you might see.
okay.
This is not something you really need to do much with. But like if I tell you to find the number of ways that you can get a club, or the number of ways that you can get a heart, you'd say, well, there are 13 clubs in the deck, there are 13 hearts in the deck,
So then, yeah.
and then the or just means add, so your answer would be 26.
Well, like, but why did I don't know. Is that a typo? Is that why you're like thing? I reckon. Oh no. I'm going crazy. Go
Not
on.
crazy. If you see this symbol right here, it means and means multiply. If you ever see this symbble right here, it means or means add.
Okay.
You guys have your formula sheets nearby? These are actually on your formula sheets. I want to introduce you to this notation. I'm sure it's on there somewhere.
I was wondering if you accidentally just put it upside down or not. So I was like, what?
Yeah, okay, it's under logical reasoning. There's some symbols there. There's a A with a little dash. Then there's an O with a line through it. Then there's like that upside down U. It's called an intersection. Intersection means you're trying to find where you have this and this. And then the very bottom one is called union. Union is where you have this or this. So one add, one multiply. Let's just do some more examples. Honestly, that's the best way of doing this unit is I've taught you the concept. Let's do more examples. So here's another typical one. You got a license plate. Car license plates consist of letters other than I or O. Anybody know why they don't use letters I's and O's?
Because
Because they look like zeros and eyes.
Yeah, I's and O's look like ones and zeros. So then there's 3 digits, but the first digit cannot be 0 apparently. And then any 2 letters. We're going to try to figure out how many license plates there are. So the first thing we've got then is a letter other than I or O. So how many letters are there in the alphabet? But if you can't use I or O, then there's 24. Then you can have any 3 digits, except the first one can't be 0. So if this is a digit, this is right. You can have 9 choices here because you can't have 0. But then this next one, you can use 0 again. So you're back up to 10, and back up to 10. And then you're back to any 2 letters. But this time it's any 2 letters, it looks like. So the last two letters, any letter, I guess you have 26 choices right here because you can have any letter you want. But then it says you cannot repeat that letter again. 25. And all of these are multiplied because a license plate has to have a letter and a number and a number and a number and a letter and a letter. You have to have all of these things to make a license plate. So that's what we're multiplying in this case. Don't worry about finding what the value is. I assume you guys can use a calculator though.
Yeah.
Does that make sense?
No, I'm lost.
Okay. So there's 26 letters in the alphabet, but you can't use I or O. So the first letter, there's 24 choices.
Got
Does that work?
Yep.
Okay. Then it says there's 3 digits. Normally there's 10 numbers you could use. But for the very, very first one, it says you can't use 0. So that's why this guy's down to 9. But you can use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 here and 10 here. And then the last thing it says, well, then there's 2 letters. So again, there's 26 letters. It looks like you can use I and O again. But the only issue now is that you can't use, you can't repeat them. So the first letter can be any of 26 letters. And the next one's only 25 because whatever you pick here, I don't know what you pick, but whatever you pick here, you can't use it again. So there's one less choice. Okay. We'll do lots of examples, okay? Okay, let's try a couple more here. Scrabble's a good one. Or years and years ago, there was this game called 4 Pictures, 1 Word on cell phone. You guys play that one?
Yeah.
It was big for like a month and a half, and then everyone stopped playing.
And then Flappy Bird.
And then Flappy Bird came out. So I thought that this was kind of a good place to talk about this, like Scrabble and like mixing jumble letter words. So what I'm going to say is, how many word possibilities could you make using these letters? E, J, H, N, I, L, P. But I'm putting words in brackets because it doesn't actually have to be a real word, okay? For example, you could try the word E, J, H, N. I know that's not a real word, but could you try typing that into like the little thing here and just give it a try? Sure. So
Basically, how many different letters?
yeah, like how many combinations do you have? Right. So let's say you did a 4-letter word. We need 4 blanks here. Let's say that you could repeat letters. How many choices do I have for this first spot? Well, there's 1, 2, 3, 4, 5, 6, 7 possibilities. So there's 7 possibilities. If you can repeat the letter again, well, then there's still 7 possibilities here. And there's still 7 there and 7 there. Or maybe a faster way of doing this, 7 to the 4. Okay, but that being said, like in this game right here, let's say you use your letter E. Can you use it again once you've used it? I'd say most scenarios, once you use something, you can't go back and use it again. You only have one of them. So this one's probably more likely. Let's say the letter can't be repeated. That's it, actually, yeah. You have 7 choices to start, because you can use any of the 7 letters. But once one of them has been used, well, then there's only 6 choices. And once one of those has been used, now there's only 5 choices. And once one of those has been used, there's only 4 choices. You guys are going to be given questions like this where they just kind of give you a scenario, and you've got to kind of figure out logically, well, what numbers should I times together? Okay, here's another scenario. 4-digit code. You can't repeat a letter, because once you use it, you can't use it. But let's say that it's a Scrabble game. And you know that you have to start your word with an E just because that's what the tile on the board is. Right? Like the E's already locked in place. How does that change it? If the first letter has to be E. Well, you start with a 1 because it has to be E. And then 6. 5, 4. Why not a 7 right here?
Because you're not using.
You've already used E. So E's out of the rotation, so there's only 6 left. And then there's 2 out, 5 and 4. Or here's a more complicated twist. Again, 4 letters. The first and last letters must be vowels.
So there's 2 vowels in the options.
Okay, so let's start with that. E and I are vowels. So the first and last letters have to be vowels. So I don't know which, I'm just going to write out, this one has to be a vowel. This one has to be a vowel. So this one has to be a vowel, this one has to be a vowel. How many choices of vowels do I have? I only have 2. But it said you can't repeat.
So there's only 1.
So then there's only 1 choice down there. That's a 2, by the way. You have 2 choices of vowel to start with. once you use whichever vowel you use, I don't know whether you're using E or I or whatever it is, but once you use that vowel, there's only one choice for the last vowel. How many other letters are there left?
5.
Okay. You can actually kind of go out of order here then. There's 5 other letters left. But then once you use one of those 5 letters, then you only have 4 left. Does this make sense?
I remember that one right. I went ahead and I got it.
Alright, let's keep trying more examples then. Alright. This is totally like, I once went to go watch my daughter Tiziane go to preschool. And they were going to line up to go to the gym. And like you can probably imagine, there's all these little kids. And the teacher says, we're going to go to the gym. And they all race to go to the front of the door. They're all fighting each other for who gets first in line, right? And so here's my question here. You got elementary school kids going to the fountain. How many ways could we arrange those kids? So let's say we got 6 kids. How many kids could be in the first spot? Well, okay, that kid cannot be in 2 locations, right? That's the mutually exclusive concept. Once that kid has taken a drink, there's only 5 kids that can be in the next spot, and then 4 kids in the next spot, and 3, and you're getting the point here, and 2. And then I want to talk about this one, the last one though. The last kid, he's kind of like, he's the one who there's no choice about. Does that make sense? Like, you ever do picking teams where it's like choose captains, and then like the person who gets picked last, really there is no choice, right? The last person has to get put on that team because he's the only one left. That's kind of what's happening here, is that last kid, he has to be last. Does that make sense? This sort of thing comes up so often that there's actually a special notation for it we use in math. And so I'm actually going to skip ahead here a slide because I think now's a good time to talk about it. It's called a factorial notation. You might have noticed this sort of concept where I'm constantly timesing the number and then dropping the number by 1 and then dropping the number even lower down. And it comes up so often that we've actually made a notation. It's called factorial. You use an exclamation mark. Believe it or not, exclamation marks are not just for English, they're for math as well. If you ever get an exclamation mark, it means take that number and basically times by all the numbers below it until you get to 1.
I don't like that.
So rather than typing this answer out as 6 times 5 times 4 times 3 times 2 times 1, and I'm kind of boring you a little bit here, what you'd do is you'd say 6 exclamation mark. And 6 exclamation mark basically means take 6 and times by 5 and times by 4. Does that make sense? Okay, really important note here. Why do you have to stop at 1? Why can't I go past 1? Why can't I times by 0? Why could I not say now there's 0 people left?
Because then there's nothing to be 0.
Yeah, you don't want to times by 0 because 0 times anything just ruins the whole thing. So you have to stop with the last person. Because of this, you guys still with me? Sorry, this is a long time here. If you ever get asked, and this would be so random if they asked you this, but if they ask you, 0 factorial is actually defined as 1. Because 0 times by anything would cause a huge problem. So if you ever have a factorial, we always stop at 1. So it seems kind of ridiculous, but 0 factorial means 1 times, I'm out of numbers. Let me go back an example now. Let's say that you're working at the ski hill. There are 9 different ski hills and 9 different employees. And the boss basically says, I need 1 employee per ski hill. So, there's 9 of you at the table, more or less, right here. I might say, you're going to ski hill 1. You're going to ski hill 2. You're doing the 3rd one. You're doing the 4th one. In a way, if you wrote it out, it would look like this. 9 times 8 times 7 times 6 times 5 times 4 times 3 times... And now I get down to this. And all of you guys are up on the ski hill, and there's 2 of you left. And I say, well, you have 2 choices. So, Latoya, you go to that ski hill. Dakota, you're the last one. You don't have a choice. Well, not that you have no choice. You have 1 choice.
What if you just said, I don't want to ski anymore, and you all back along?
Well, okay, that changes the question, but assume that everybody has to go do their job. So,
Otherwise you get fired.
you know, sometimes when they say that you have no choice, from a mathematical point of view, that's actually not true. If you have no choice, actually, you probably have 1 choice, which means you don't have a choice, but you still times by
It's like
1.
when your mom volunteers.
Sure, yeah, when you get voluntold for something. Okay, I want to talk about this next one here. How would this change if there were 11 employees?
then there's usually.
Well, you still have 9 ski hills. So give me a second here to write this out. There are still 9 ski hills. Focus, 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 focus.
So I really children.
I know, you really are. And some of you have done this before, like he's bored out of his mind, but focus, okay? Okay. There's 9 locations for 11 people to go. So I have 11 choices. Then I have 10 choices. Then I have 9, then I have 8. Follow this up, okay? 7, 6, 5, 4, 3. Why am I stopping them?
Because there's 2 extra people.
There's 2 extra people. Or maybe another way of looking at it is there's only 9 ski hills.
2 of you get fired.
2 of you, sure, 2 of you get fired or you don't get to go to work, right? Well, there's actually a way in which we can write this using factorial notation to save time. Here's how we do this. This would be written as 11 factorial divided by 2 factorial. Let me talk about how this is going to work here. You know this. Okay, so here's why this works. 11 factorial really means take 11 times by 10, blah, 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 blah. But you get to, no, you go all the way down to the bottom, you go all the way down to 1. 2 factorial means 2 times 1. Hopefully you can see this 2 and this 2 cancel, this 1 and this 1 cancel, and what you're left with is the 11 through 3 combo that we actually want. So as a short way of writing this, sometimes what we'll do is I'll say there's 11 employees. There's 11 employees. And 2 of them don't work. 2 of them get fired, basically. So if you have 9 people and all 9 get a job, that's fine. But if you have 11 people and only 9 of them get a job, the fast way of answering it is divide by the people who are not going to get to go to work that day. That makes sense? Let's try another one. Okay, you've got 9 people on your baseball team. Baseball, by the way, requires 9 people, in case you're not aware. So 9 people on the team, you need 9 people. How many different batting orders can you have? Well, all 9 people are getting used. So it's the same question. It's 9 factorial.
Oh, wow.
Now you could, if you wanted to, write out 9 times 8 times 7 times 6 times 5 times 4 times 3, but that's a waste of time now. Sometimes it's just faster to just write 9 factorial. This is a very real-world scenario. You're playing sports. 15 people want to be on your team, but only 9 can play. We're going to have cuts. Who's riding the bench? 6 of them. So there's 15 people total, but 6 of them don't get to play. Or another way of putting this would be there's 15 choices, then there's 14 choices, then there's 13, then there's 12, then there's 11, then there's 10, then there's 9, then there's 8, then there's 7, and the remaining 6 people, either you're cut or you're riding the bench, I guess. Or should be.
Oh, I didn't get cut. I'm on the bench. Okay. I didn't get cut. Pretty small.
Does that make sense, though, this concept about how sometimes not everybody makes the team? So the fast way of doing it is just divide by the kids who don't make the team. On the diploma, there's a few ways they might write this. They might actually tell you what that number is. But that number is kind of ridiculously big, right? So they might phrase it like this might be A, and B they might write it as 15 factorial, and C they might write it as 9 factorial, and D they might write it as like 15 over 9. So sometimes they won't actually ask you for the number value, because usually the numbers are so large it's ridiculous. So you have to be able to recognize the notation instead. Okay, the bottom 2 are actually meant for my 30-1 class. I just stole the slide off of there. So let's at least just do the top couple here, just to make sure we get this concept. If I did 10 factorial divided by 7 factorial, what's left? Don't use your calculators. I haven't even shown you your calculators yet, have I? You are. 10 factorial means 10 times 9 times 8 times 7, blah, 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 down to 1. 7 factorial means 7 times blah, 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 down to 1. Cancel like crazy. Yeah. So 10 times 9 times 8. Okay. I just realized I should show you in your calculator where to find this button. There's a button. There's an app for that. Yeah. There is an exclamation mark in your calculator. So if you want to type in 10 factorial, first type in the 10. Then, you guys know where the button math is? Press math. Math is second, then down to alpha, then down to math. Okay. The unit we're focusing on is called probability. So you have to press the over arrow till you get over to probability. And if you go down a couple, there's an exclamation mark just sitting right there. Can you guys find that? So if I take 10 exclamation mark and divide by 7 exclamation mark, the answer is actually 720. You find it?
Yeah. It's exciting. This thing is the smartest thing ever. I don't understand. It blows me away.
I did not get that.
How is it?
You think it's the same thing as me?
Oh, I did you get it?
720.
What are you doing with your mouth though?
Girl, yes.
Alright. Okay, let's move on here. Devin's so bored he's playing like a sinker. Okay, let's try another example. Sorry, by the way, this unit is very much going to be, I'm going to do basically a crap load of examples. My goal is to try to show you all sorts of different scenarios they're going to test you on. Hopefully you'll agree though, the math, like the actual timesing of numbers here, it's just multiplying stuff together. So, okay, this is a very classic question. This is the photo question. You got 7 people for a photo. How many ways can the 7 people line up for a photo? Well, maybe the best way of writing this would be like that. There's 7 people. All 7 of them are getting used. You have 7 choices, then 6 choices, then 5, then 4, then 3, then 2, and then the last person just has to stand. This is a very classic twist, though. Typically, we do a lot of these in Dash 1 math. I want to make sure you guys have seen this in case it comes up on a diploma. I call this the Brangelina question. It's like you guys have already heard this spiel, haven't you? You have to like rate whether I did better the first 10 seconds. Okay. Sometimes there's a scenario where 2 people, they fall madly in love with each other, and like you just can't separate them. Maybe you know friends like this, where like they're basically attached at the hip. What was that?
Like, go away. Stop saying it.
When Melissa and I first started dating, we went to a friend's birthday party, and like they made sure that we had chairs at the opposite side of the table, so we couldn't sit next to each other. We're so angry with our friends. Probably had this happen before. So if you ever get a scenario where someone has to stand next to each other, here's how you approach it. I'm just going to write out some A, B, C, D, E, F, G. There's 7 people there. A and B, they're dating. The best way to approach this then is to treat A and B as though they're one person. Because really, they're always next to each other anyways. So now what you have is rather than having 7 people, you actually have 6 people. And I like to call this a Brangelina question because it's like Brad and Angelina. You know how they combine their names and call them Brangelina, the tabloids? Because they're basically they're one person. Never heard that before?
Yes, I have it.
Oh.
I don't know.
My references are getting outdated. I need to think of something new. Okay, what do they call Kim and Kanye? Have they blended their names together yet? Kimye?
Yeah.
Okay. Is that a better reference now?
Same.
Just imagine the scenario here where there's 2 people that are they're always at the hip. Basically call them one person. Because they are one person.
And then it'd be like 6
So now the answer is 6 factorial.
factorial.
Except for one issue. There's not actually 6 people. Technically there were 7.
But they don't.
These 2 people, although we're counting them as one person, we could flip them around still within their little order. And so what we have to do is we have to times it by the fact that Brad could go first and Angelina can go first and Brad second. Or it's possible that Brad could go first and Angelina second. Let me show you an example of this with manipulatives. I'm going to steal a calculator. Okay. 1, 2, 3, 4, 5 objects. Can you guys all see here? I'm taking that spot over. here are 5 people. Okay? And if I want to rearrange them, it's 5 factorial. Except this is Brad, this is Angelina, and they are so in love with each other that they just can't be separated. Well, now we have 4 objects. We have water bottle, pen, pencil, and Brangelina stuck together as one
But then
object.
you can flip them over.
That's the thing. You can do all of these rearranged here, or you can flip it over. Does that make sense? And so what you have to do is you have to take your 4 factorial and times by 2, because there's 2 ways in which you can rearrange the Brad-Angelina combo. So in this example here, if there's 7 people, the way you solve it then is you do 6 factorial and you times it by 2 factorial because you could flip them around. The stand next to each other twist is a very common one for my -1 math students. I think it's reasonable to expect this on the -2 test as well. The even harder one, though, is the question where it's the awkward stage where Frank and Jill, or Brad and Angelina, they just broke up. And for some reason, we're taking a photo with Brad and Angelina still, but now they can't stand next to each other. Now, that doesn't mean they have to be on opposite ends, but it means you have to have at least a 1-person buffer in between. So it could look like this. Brad, Chris, Angelina, Dalton,
Frank.
I can't think of an E name, Eunice, Frank, and Gloria. Or it could be Brad, Chris, Dalton, Eunice, Angelina, Frank. But the one thing you can't have them is where they're actually directly next to each other. So here's how you solve this problem. If 2 people cannot stand next to each other, focus please. I know, I'm sorry this is such a long lesson. If 2 people cannot stand next to each other, what you do is you find the total number of possibilities total. Total number total, which is 7 factorial. There's that many total ways to arrange people. If you subtract the ways in which they are together,
So you can subtract.
wouldn't the leftover bit be the ways in which they are not together?
What?
Because either they're standing next to each other, or they're not. Aren't those the only 2 possibilities? So if I find
Subtract 2?
all of the, well, not 2, the answer was 6 factorial times 2 factorial. Here is the total number of ways they could line up, no restrictions. Here is the ways in which they are next to each other.
2 factors.
6 factorial times 2, because I know there were 7 of them, but we're taking 2 of the 7 people and merging them into 1 person, because they're 1 person. So now there's 6 people left over, but the Brad-Angelina pair, you could flip them back and forth. So this is the way in which they are next to each other. So if you take the total and subtract the ones in which they are next to each other, that is the ones in which they're not next to each other. Okay, don't freak out over that one too much. I'm not expecting that. They could, but I'll do that one some more later. But that's a really common twist. That's not stand next to each other question. I'll try again later. Okay, let's do some diploma questions. These are old diploma questions on this topic. Let's try them and then we'll call it a day. Okay, so first question. You've got 5 light switches. How many different ways could we turn them on if they're on or off?
5. Who's the power 5?
That's the answer, yeah. Because there's 2 choices, on or off. Then there's 2 choices, on or off. Then there's 2 choices, 2 choices, 2 choices. Be careful, actually type it out.
It's not 25, it's 32.
32. 5 times 5, which is 5 squared, is 25, but that's not it. That's 32.
I would got that one.
Okay, this is a very typical kind of question where hopefully you'll agree compared to the last unit. This is more like just look at it, interpret it correctly, do a really small amount of math, and it's a lot shorter, okay? Let's try another one. Okay, so a couple is going to have a baby. So they've narrowed down their baby names. It's going to either be Alicia, Nicole, or Sydney. How many choices of names do they have then for girl? 3, I guess. And, keyword here, they're going to give her a middle name. So they're going to give her a first name and a second name. So that's if it's a girl. If it's a boy, they have 3 choices for first name, and they're giving him a second name as well. And there's 3 choices there. Now here's the issue though. What do I do with this now? And the answer is you add it. Can you have a girl and a boy at the same time? If you're having one kid?
No. Well, maybe.
Yeah, okay, let's ignore the possibility of genetic defect, right? Like, you're either having a girl or you're having a boy, right? And that's the key word, is you're either going to have a girl or a boy. So we need to add these together. There are 6 different girl names you could have. There are 9 different boy names you could have. It's either a girl or a boy, so therefore there are 15 ways you can name your kid.
I'm sure it was.
I mean, if you're not really picking gender names, but you know, would be
Well, yeah. Okay, let's try another one here. A security company has some different letters in a key code. They're all the vowels. How many different ways can you make a 3-letter code if letters may, like no letter may be repeated? Okay, well there's 3 letters. There's 3 different things in a
Kaiser
letter.
Wadsworth, can you please come to the office for checkout?
How many choices
Kaiser
do I have
Wadsworth,
at this point
please
right
come to
here?
the office
1,
to
2,
check out.
3, 4, 5, 6. But you can't repeat though, right? Well, 6 factorial means you're using all 6 letters though. You have 6 choices for the first one. Then you've used one of them, so there's only 5. And there's only 4.
But that's the one.
Stay with me if you can. We're not done though. What is 6 times 5 times 4 though?
Into the list of letters. So you add
120. Okay, so here's where you need to use your critical thinking skills though. That's not what it asks you. It says if G is added to the list of letters, how many more codes are there?
7 more.
Well, okay, so you still have a 3-digit code. Now you have A, E, I, O, U, Y, and G. So now you have 7 choices. But then there's 6 choices for the next one and 5. So someone help me out here. What's 7 times 6 times 5?
210.
Okay, so you used to have 120 codes, but now you have 210 codes. How many more codes are there if you go from 120 to 210?
90.
How do you get that?
You subtract 210. Well, 120.
Say basic science.
Oh, math is so sad.
I'm going to say this a lot this unit.
Basic.
The math is not hard. You need to add and subtract and multiply and divide numbers.
Hey, got that.
The hardest part though, stay with me please, I promise, I'm sorry. Okay. Try to focus though. The math is not hard. You're adding and subtracting, multiplying and dividing. The hardest part is can you interpret the question and figure out how to use these skills to solve a puzzle.
Yeah.
Okay, last one, then I'm going to let you go. Okay. Okay, so you guys are doing grad. Grad council is going to make them select 1 salad, 1 main course, 1 side, 1 veggie, and 1 dessert. Well, there's 1, 2, 3, 4 salad choices. And you have to choose a main course. There's 1, 2, 3 main courses. And you have to choose a side dish. There's 1, 2, 3, 4, 5 choices there. And you have to choose a veggie. Yes.
I can't.
You can't have like.
None.
Well, no. Apparently, it says you have to choose one. So there's 1, 2, 3, 4, 5 of those. And you have to choose a dessert. So there's 1, 2, 3, 4 of those. So 4 times 3 times 5 times 5 times 4 was 1,200. All right. Can I give a quick summary and then you guys can go? Okay. New unit, very different from what we've been doing before. Like, very different. Like, they're polar opposites. Not that you need to not have critical thinking skills before, but that's all this unit is, critical thinking skills. If a scenario requires 2 things to happen, an AND scenario, you multiply. If you have possibilities in an OR scenario, you add. There's certain twists, like you can't use something again. Then you need to drop the number down by 1. That's the factorial exclamation mark thing. There's also the possibility of things like you have to have 2 people sit next to each other, or you can't have 2 people sit next to each other. Okay. Here's what I'm going to recommend you guys do. There's a few sheets that I added to the duotanks. If you'd like to, take a look at some of those questions. They're not, there's not much work to them. Like they're just problem solving scenarios. So maybe try a couple of them off the first page even, just to see what you get. And then we'll pick this up again tomorrow.
So can I take this?
Yeah, take one with you. Does that sound good?
Yeah.
Okay, tomorrow we're going to do permutations, and my goal is, in the hour we have, I'm going to try to go through the whole lesson as well, so that I've covered 2 topics before next week. Sound good? Okay, you guys can take off. I'll see you later.
Sorry for being so.
That's okay. I know it's a long time. I need you guys, though, if possible, to be helpers Monday, Tuesday, if you can.
Okay.
Because you've done this before, right?
Yep.
Awesome.
You can put me down, please.